Hey guys, welcome everyone. This is Peter with Cybrack. Let me make a quick introduction to this free Palo Alto Networks video series so you guys know exactly what's covered and what's inside. Hello, this is Palo Alto Firewall for Beginners by Cybrack. I am Peter Kolesny. I'm gonna run this class for you. This course is meant to show you how to perform a basic initial setup of a Palo Alto Networks firewall when you take a new device out of the box and you have no connectivity to the firewall system. You need to give it an IP address for administration. You want to configure interfaces, basic settings, and eventually the policies. So it's meant to show you how to quickly configure a PAN-OS device, Palo Alto Networks Firewall, next generation firewall system, without going into too much details for each of the different features and technologies that we will cover. So I will show you how to perform this basic configuration, how to get the firewall up and running, and how to control communication that goes through the firewall. What we will look at in particular is going to be how to connect to the firewall for the first time. I will show you how to configure an IP address using a console, so you could then connect to the firewall using a GUI from a remote location, from a management station. And next, we will take a look at a bunch of basic firewall settings, including the concept of so-called service routes. Then I'm going to discuss configuration of firewall interfaces and security zones. We will, moving on, talk about connectivity testing to see if we can reach locally connected devices and also if locally connected devices can reach us. Another topic is how to configure routes on the firewall to obtain connectivity across the whole network, to eventually show you configuration of the security policy. I'm going to explain the implicit policy rules and then show you how to add custom roles. We will also spend a little bit talking about policy processing. And finally, I'm going to enable NAT so we can test our deployment. As you can tell, we've got a nice bunch of topics to go through. So let's don't waste our time and start looking at them one by one. We will now take a look at how to connect to the firewall to eventually obtain GUI access to the system so we can start with other configuration. Now, this is something that is pretty much critical for every single case when you deploy the firewall for the first time. Depending on the appliance type, like physical versus a virtual firewall, an IP address on the device might be actually pre-configured, but it doesn't necessarily gonna fit your network, your management network, or basically a network that you want to use for management. So because of that, one of the first things that we will do when we take a firewall out of the box or when we install a virtual firewall is gonna be specifying an IP address for administration. And this IP address is something that we will then use for connectivity with SSH, maybe Telnet, or even API. API is going to be the third method that we can use for a connection to the Palo Alto Networks firewall. We've got console, we've got remote access with Telnet SSH, and we've got API, where API stands for Application Programming Interface, and is something that will be used by our scripts or applications to connect to the firewall. As I said in the beginning, the goal in our case is going to be to first and foremost configure an IP address on the management interface so we can then connect with a GUI or maybe SSH to access the command line in a remote fashion. The command syntax that we will use to set up a firewall for remote access, either command line or GUI based, is going to be set device config. And the first thing that we will want to specify here on the console, just through the console, is going to be to tell it what type of address assignment we want to use. Now, if we go for a DHCP, a DHCP-client option, this means that we want to use DHCP for address allocation. And in this case, we are pretty much done with the config. Versus if we select the static option, which is what I'm going to use, it means that we want to assign an IP address manually. In the second case, it also means that we will have to specify the address itself, which is what we will do with the aid of the other command, set device config system IP address. Okay, once we are done with that, we will say show interface management to quickly take a look at the results of the configuration. Let's go ahead and take a look at this. In our network, as you can tell, we will use the management interface of the firewall for administration, and I will be connecting from this Windows station 172.16.1.200. So this is the address of the Windows device that I will use to get to the firewall, open the GUI, use the GUI access. And then on the firewall itself, we will give it .10 on the management interface. So 172.16.1.10 is what we want to give this firewall to connect to it. Let's take a look at that. Let's just click on the firewall connect for the first time using the console connection. Admin, this is the default credentials, what you will use to access the firewall for the first time. Everything is lowercase here. Admin with a password of admin. Now notice that the firewall is going to ask you to change the password here, and I'm going to set a password to match what we have here, Cybrek PW exclamation mark. So I will just specify the old one and then put new password and confirm so we can access the CLI. Okay, so as I mentioned, we will now use the set device config system command, set device config system type to start. But this is something that we will have to do from the configuration mode. So I will first and foremost say configure and then set device config type, system type. I can either say DHCP client or static. I'm going to say static here, and then set device config system IP address 172.16.1.10. This is what I want to configure on the firewall. Then we will say what is the net mask. It is /24. So 255.255.255.0. And the last step is going to be to give it a default gateway. I'm going to say 172.1.254. We don't really have it. I don't need a default gateway because my Windows PC is directly connected here. So pretty much the only thing we need is the address and the net mask. With that in place, we will issue the show. Let's go down to the privileged mode, to the exec mode, and let's say show interface management. So first thing we want to take a look at here is going to be the status. We see that the interface is up. It says it doesn't know what's the address is, what's the net mask, because we haven't committed the configuration. So we need to go back to the configuration mode and say commit. Remember that PAN-OS, or just Palo Alto Networks Firewall operating system, is what it doesn't take your configuration changes immediately. In order for the configuration changes you make on the system, you have to install them, which is what is preferred with the commit command on the command line, or for the commit button on the GUI. So once we commit and the process is complete, that means that the configuration got installed on the firewall and is now active. Okay, let's wait for this configuration to be installed. We are almost done. Here we are at 98%. We see that message commit was successful. So let's go down to the exec mode and say show interface management once again. And now we see the settings we configured here. The interface is up. And when I eventually connect, we will also see we can actually see some packets being received and transmitted right now. So the next step is going to be to go to my management station. I'm on Windows PC. This guy here, 172.16.1.200. And we will just try to connect to the firewall, HTTPS to 172.16.1.10. Go to advanced, proceed. The certificate problem is related to the fact that I don't trust the self-signed certificate of the firewall on this PC. You could fix this problem if you install the firewall certificate to the trusted certificate store of this Windows station. Okay, so put the right password, the new password that we configured when connecting for the first time. And let's see if we can connect to the system. Just in case you want to modify or just change some of the settings configured on the management interface, you still have that option to use the GUI to make those changes. Just go ahead and take a look at device setup interfaces and select the management port. Device setup on the left. Interfaces, let's switch the tab and just click on the management interface, and this is where you can see all the configuration that we defined for the command line. If you make the changes here, don't forget to commit the configuration so they take effect. Now, once we've got the management interface configured and we can access the firewall remotely for administration, another thing we could possibly take a look at is the basic settings of the firewall. In this case, I'm thinking about stuff such as DNS server addresses, time synchronization, maybe specifying and configuring the Palo Alto Networks updates. And stuff like that is something that we will take a look at from the device and setup menu in most cases for most of those things. Let's go to device and setup and then start with management. We've got general settings that we can configure. In order to make changes here, just click on the tool icon, specify the host name for the firewall, like for example FW1, configure a domain. In my case, it is cybrack.com. You could also specify a login message, so when you connect to the firewall, when you log in, you will see the message displayed. This is also where we can specify some other settings, like the certificate related settings for the management network. This is where we can specify the time zone or set the time manually, and also enable some settings, additional settings, such as, for instance, the advanced routing mode. Okay, advanced routing mode is something that gives you access to more routing settings than the standard mode, and stuff like virtual routers and additional routing settings is what you will be able to look at when you turn the advanced routing mode on. But this is behind the scope of this session. What I want to do at this point is just to configure the host name and the domain name. Maybe let's also change the time zone to something else. I'm gonna go for, let's go for New York here, and just okay for that. Okay, this is the basic stuff for general settings. Good thing to start your configuration. Bunch of additional settings you could consider would be additional banners or messages. And this is also where we can configure some other options related to the system behavior, like authentication settings, or to administration, like password complexity. We also have logging and reporting settings for monitoring, what we can specify. But in my case, it's pretty much the host name and then the domain name, what I wanted to configure here. Okay, another one that we have is DNS, NTP, and update server settings. So this time you want to switch from device setup management to device setup and operations. Excuse me, not operations, the services. We want to specify, edit the settings. Update server, I want to leave the default value. Once you've got DNS in place, the firewall is going to be able to perform the resolution, figure out the actual address to connect. I'm going to specify 8.8.8.8 for DNS, because my firewall will essentially use a DNS that is hosted by Google. I don't have any internal DNS server. You would normally have it. You would normally have probably an Active Directory, a domain Active Directory setup with DNS. In my case, I want to use external system. So there will be just one DNS configured on my firewall. What else? One more thing is going to be NTP server. I'm going to specify pool.ntp.org, which is another public service. So in this case, I don't have a internal NTP server, and I want to use external addresses, external, in this case it's actually a cluster of NTP servers. NTP and DNS in this network will be configured as external services. And the reason I configure these services as external, one of the reasons, is that I also want you to think about routing configuration, because the key thing to remember about PAN-OS is that by default, the firewall is always going to try to use the management interface to access external servers and external services. In order to change it, we will want to configure what is known as service routes. Just to make it clear, if we were to leave the configuration of those basic settings like that, with DNS configured as 8.8.8.8 and NTP server configured as an external service, the firewall would not be able to communicate with those servers in this network, because the management interface is what the firewall will eventually try to do to connect to them. And in my case, management network is a kind of like out of band. It is restricted. It is separated from the internet. It has no connection to the internet. So because of that, in order to get this setup work, we would also have to tell the firewall that for DNS and NTP, it should be using the Ethernet 1/2, an external interface for connectivity. So we want to force the firewall to use this interface for external services, specifically NTP and DNS. And the way we can accomplish this is with the aid of service routes. Service routes is something that we can configure from the same menu, device setup services, under services features, service route configuration. As you can tell, the management interface will be used by default for all those external services, which means that we want to click customize, and there is now two ways how we can define changes to this default configuration. One is going to be to specify the interface, source interface for this or another service. Like for instance, for DNS, I want to click on DNS and I want to change and select another interface. Ethernet 1/2 is still down, so I am not able to do so, but we will get back to this after we are done with firewall interfaces. For now, I just want to show you where to do the configuration. So we will also have to do the same for NTP. Tell it to access NTP servers, use a different interface. And the second way is going to be to go to the destination tab and specify the destination, like for example 8.8.8.8, and specify the interface from there. So the bottom line is that for service routes, you can configure them in one of two ways. You can either deploy them on a per external service basis or on a per destination basis. It is now time to start thinking about building connectivity in our network. We will accomplish this by configuring firewall interfaces. You can think of an interface as of a point where the traffic enters the firewall or leaves out of the firewall after being processed. So it's an entry point to the firewall for the traffic so it can get processed, so it can get inspected, and when the firewall says, I'm okay with those packets, I will allow them to leave through typically a different interface from what they entered the firewall on. Now, there are a few different types of interfaces that are available on PAN-OS. You could configure them as layer 2 ports, as layer 3 interfaces. You can do VLANs, you can aggregate those ports, but we will take a look at a simple case where we will just use the most typical, the most common interface type known as layer 3. Also remember that a given interface will never process the traffic unless it is assigned to a so-called security zone. Now the question is what a security zone actually is. And now security zone is something that is gonna make a logical boundary that the firewall is gonna use to eventually control the communication. Now the idea behind security zones is that we will use them to segment our network into those more trusted or less trusted portions, and the traffic is only gonna be allowed between these different zones, assuming that the firewall's policy allows for that. So for instance, we can create a security zone called inside, which is meant to be connected to trusted devices like our internal users. We can have another security zone called outside, external, or internet, which will be connected to the external world, typically the internet. We can have other zones for specific device types, like for instance for special user departments, maybe human resources, maybe security operations. We can have a security zone for certain applications or servers, like for DevOps, test applications, the test servers, and similar. So the idea is that the more security zones we have, the easier it is going to be to break down the whole communication, make it more granular in terms of inspection and control with the aid of security policy. Because as we will see, security policy is going to be made of rules where one of the main conditions that will be used to define those roles is going to be security zones. So in general, the more security zones you have, the more granular control you will be able to enforce on the firewall, but more administration roles it is going to require. Another important point about security zones is that they are related to the implicit firewall behavior. This is related to the default filtering logic of the firewall. As we will see later in this course, the firewall uses two implicit security policies, security roles, one for infrazone and one for interzone communication. So what's the difference between them and how is this related to the concept of security zones? For instance, assuming that we would configure security zone called in for interface 1/1 and use a different security zone like out for Ethernet 1/2, the communication between these two interfaces, since they are part of different zones, would be classified as interzone communication. And the default behavior of the firewall for interzone traffic is to drop it. So this means that without defining any custom or just specific security policy rules meant to explicitly permit communication from the inside to outside or outside to inside, the firewall would always drop communication that is trying to traverse through these two interfaces, through these two zones. And now, on the other hand, if we were to use the same zone on these two ports, like for example, inside and inside on both interfaces, that would be treated as intrazone traffic, the traffic that would be traversing from these interfaces, which based on the implicit or just default firewall policy would be allowed. So that communication would be permitted. And because of that, it is very important to carefully plan configuration of security zones and their assignment to the interfaces. Here also remember that a single interface can only belong to one security zone. You cannot assign more than one security zone to a single interface. The firewall is not going to allow that. It is always going to override a zone with the new setting. So single interface equals single security zone. Remember about that. We will now configure interfaces and zones on this firewall. This is something that we can do from the Network tab. Let's switch to Network and start with zone definition, because zone is something that we will then want to assign to interfaces. So under Network and Zones, I'm going to say Add, and I will call my first zone In, where I'm going to set the type to be layer free, because I will be using layer free interfaces, and we will accept. And then we will configure another zone called Out, still at layer free. Okay. And now with zones in place, we can go to interfaces and start configuring them one by one. And based on our topology and also what I mentioned earlier, we will want to use the in zone for Ethernet 1/1 and then out for the second interface. Let's start with 1/1. We will give it an IP address of 10.1.1.10/24, where the outside interface is going to get 192.0.2.10/24. So this is what we want to configure. Moving on in this portion of the course. I'm going to go to the interface, click on it. And the first thing that I want to set here on the port is going to be the interface type. Remember that my zone was configured as layer 3, which means that my interface, in order to take the zone, it must be also configured as layer 3. And the reason that I'm using layer 3 interfaces is that the firewall will be essentially routing packets between our different zones. Okay, there is also a concept of so-called virtual router. At this point, you can just think of it as of the routing table. So assuming that we want all these interfaces to be part of a single routing table, we will just make them part of the same virtual router. And there is a default virtual router called default, so we will use it. We will not be building a dedicated virtual router instance. Next, I want to specify the zone. I want to set it to N and configure an IP address on this firewall. This is going to be a static address, 10.1.1.10/24, and we will just OK. And we should see that the interface, the link state of this port, is going to eventually turn green. Let's also configure Ethernet 1/2. It's going to be the same process. What I will take to finish this configuration, I'm going to start with the type, layer 3, virtual router is set as default, and security zone, in this case, we will use the out zone, and of course an IP address will also change to 192.0.2.10/24. Okay, so let's refresh. At some point we should see, once I commit the configuration, we should see that these interfaces will eventually come up. Just one more thing before we commit, I want to go back to device setup services. Remember that I also said that in order for the firewall to communicate with external services, in order to force it to use something different than the management port, we want to explicitly configure a service route. So again, we want to define service routes for NTP and DNS to use the outside interface. So for DNS, I'm going to choose Ethernet 1/2, the outside interface, and we will do the same for NTP. Use an outside port. And we will now commit to install this configuration. We will now have to wait until the firewall installs these changes. And when this configuration becomes active, we should be able to eventually test connectivity. Okay, so now we can tell that the link state is green, which means that the interfaces are up. I'm going to go to the firewall's command line, and I'm going to use the ping command, where I'm going to specify the source. In case of PAN-OS, you want to specify the source to make sure that the firewall uses the right interface to generate ping packets. And we will try to ping router 1 from Ethernet 1/1, and then router 2 from the outside port to confirm connectivity. So 10.1.1.10, this is my inside interface, and I want to ping a host 10.1.1.1, which is router 1. We see that we have connectivity, and let's also try to ping from 192.0.2.10. Try to get to router 2, which is on the outside. We have connectivity here as well. Before we move on and take a look at the routing configuration, I want to go back and talk about connectivity here, basic connectivity tests. we have just saw how to test connectivity from the command line with the interfaces being up and configured. But the problem is that if you were to try to test connectivity and not directly from the firewall, but from the devices around the firewall, trying to ping the firewall and not vice versa, you would see a problem related to the default implicit behavior of a PAN-OS. So we saw that the firewall is able to ping the locally connected devices, but what about if I were to connect to router 1 and try to ping the firewall? We see that in this case, the result of the test is failed. What I'm trying to say here is that if you were to use those devices to test connectivity after configuring interfaces of the firewall, you could run into an impression that there is something wrong with the configuration because the firewall does not reply. It seems that connectivity is broken, which is not necessarily the case. So what's the problem here? The default behavior of the firewall is that it is going to block all management communication destined to its data interfaces unless you assign a special component that is known as a network profile, which is where you will tell the firewall what type of services, management traffic, you want a given interface to accept. So we can control HTTP, HTTPS access, SSH, Telnet, SNMP, and also ping. Now, once we create a network profile from network profiles, we will want to assign it to an interface to start working. So let's go ahead and take a look at this. I'm going to go to network, down to network profiles, choose interface MGMT, where we will configure a profile for our data ports. I'm going to call it data ports profile, where I'm going to accept ping as a service that I want to process on those interfaces. Now, also notice that you've got a section called permitted IP addresses. You could be more specific in terms of what devices will be able to connect to the interface with these management services and protocols. You would just have to put the addresses of allowed or just trusted stations to this list over here. But we will just configure a ping as one of the allowed, the only allowed management service. And now in order to make it work, we will have to go back to interfaces and reconfigure them, assign them this profile, which can be done from the Advanced tab, Advanced, Management Profile, select a data ports profile, so the profile that we have just defined, and let's do it for both interfaces. You may only want to use it for the inside, so the trusted devices can detect the firewall, but in my case, I will do this on both sides of the network, trusted and untrusted. I'm using a single profile for both of these. Just don't forget that for the changes to take effect, we need to commit them. And when this configuration becomes active, the firewall starts using it, we should be able to establish connectivity, reach the firewall interface even from the locally connected devices. Okay, so we see that the firewall's configuration had to be installed because we now have connectivity. Another thing we'll now take a look at is how to configure routing on the firewall. We have two types of, or just two routing methods that we could use on PAN-OS. Certainly the easiest way is going to be to just configure static routes for network virtual routers and static routes. Or as an alternative, you could also use dynamic routing with RIP OSPF, BGP. You could even configure IP multicasts and use some advanced routing features such as policy-based routing, or even perform route redistribution. And as I said earlier in this session, the advanced routing engine, or just advanced routing mode, is going to even give you access to some more tools and options for the different routing methods and protocols. But we will do the basic stuff. We will configure a static route to point to router 2 on the outside, so the firewall knows how to get to the internet. So this is going to be a static default route where I'm going to point to router 2, and then on the inside we will use OSPF. We will run OSPF with router 1 in area 0 in the backbone. Router 1 is already pre-configured, so we should see that once the adjacency comes up, the firewall is going to learn about 10.11.11/24 prefix. Let's take a look at this on the GUI. I'm going to go to Network and then Virtual Routers, because Virtual Router, remember, is what kind of like makes our routing table. Our interfaces belong to the default instance, which means that this is the instance that we want to modify. Static routes, let's start with this. Let's configure a default route. I'm going to add a route for 0.0.0.0/0 with a destination of router 2. Excuse me, this is the name, so I'm going to call it default-route. This is the prefix, 4 zeros/0. And then I'm going to say that the default route is reachable out of Ethernet 1/2 with a next hop address set to router 2 192.0.2.2. I'm going to leave the default admin distance metric. The routing table is, of course, set to unicast. We want use bidirectional forwarding detection or path monitoring. This is the simplest configuration for the default route we can get. And then we will switch to OSPF from static routes. We will enable the OSPF process. I'm going to give it a router ID of 10.10.10.10. And we will configure the backbone area. Notice that you want to configure the backbone as 4 zeros. That's the syntax that the firewall is going to take. This is going to be a normal area where the interface where I want to put to the backbone area is going to be my inside, which is Ethernet 1/1. 1/1 goes to the OSPF process. We only enable OSPF on the inside. Okay, no virtual links, no authentication, no advanced changes. It's just this single interface, and let's go ahead and quickly commit this change. I'm going to close. You don't have to keep the commit window open. You can always go ahead and take a look at the commit status and other tasks over here. The way that we will verify our routing configuration is by clicking on more runtime stats. Again, we are still with network and virtual routers. So more runtime stats. It's going to display the content of the routing table here. And if we take a look at the OSPF tab, this is also where you can verify the adjacencies. And now we see that the adjacency is up. We have established an adjacency with router 1. We go back to the routing table. We should see that we learned about the 10.11.11/24 network. Let's refresh, and we see that the prefix, OSPF prefix, is Over here, we also have a default route pointing to router 2. Okay, so if I were to go back to the command line of the firewall, I should be now able to ping from the inside interface. I should be able to get to 10.11.11.11.1, which is the Ethernet 0/1 of router 1. And I should be also able to get to the Ethernet if I change the source to 192.0.2.10 and try to get, let's say, to Google's DNS. So it tells me that I have full connectivity in this network, at least from the firewall's perspective. Moving on with our session, we will now talk about security policy, which is going to make one of the main components or just one of the main places where you will look at when working with PAN-OS. Because stuff like basic firewall initialization, initial setup, like when you configure IP addresses, when you set up management access, when you define addresses of DNS, NTP, update servers, this is something that you typically configure only once. And when everything is configured fine, the firewall has connectivity, routing is properly deployed. Most of the other things that you will do on the firewall is going to be related to policy administration. So security policy is obviously this single place where we will define our roles, or basically tell the firewall what type of communication, what type of traffic we want to permit across the system, what traffic we may want to inspect, or maybe what traffic we may simply drop because we don't want it to cross between the different segments. And our security policy can be thought of as a large database of rules, where each of those rules is made of so-called attributes. Attributes can be broken down into two types: required and optional. Required attributes include the rule name, rule type, intrazone versus interzone versus universal. We've got security zones for the source and destination, and application and action. So this is something that you need to specify when you configure a rule. Now, instead of an application, technically you can configure a port number, a service, and specify so-called application default inspection. But the rule name, type, zone, and action is what we need at minimum in every single security policy rule. Optional stuff is going to include elements like IP addresses, like logging settings, like security profile configuration, where we enforce other advanced inspection settings. So something that you don't have to configure when you define the rules. And another important thing to remember about security policy is that it is processed top-down. For instance, if you have 3 rules, 1, 2, and 3, and by the way, as I said earlier, security policy is also going to include 2 implicit rules. I'm going to call it implicit 1 and implicit 2. The implicit one is the intra zone rule that allows communication that remains within a single security zone. Remember, when you get a packet on interface, let's say Ethernet 1/1, which is part of the inside zone, assuming that the packet wants to leave across another interface that is part of the inside zone, based on that implicit intrazone rule, we will permit the packet, assuming that other rule higher in the policy does not block it. So top-down processing, which means that we check, evaluate the rules one by one, starting with rule number 1, looking for a match. We have a match, we stop evaluation. This is important. When one of the rules is matched for the packet, the firewall is not going to check subsequent rules. It's going to enforce action based on what the rule that was matched says. So that's the idea. If I have a match, let's say rule number 1, I'm not going to check other rules, say packet 1. A packet 2 is we don't have a match for in rule 1, 2, and 3, so we now go and start evaluating our implicit rules. Second implicit rule is for inter-zone traffic. So assuming that packet 2 is let's say from inside to inside, we will accept it. And if packet number 3 is not going to match any of our custom rules, but it is for inter-zone traffic like inside to outside, we will drop it based on the second implicit rule. Now, if we have packet 4 that doesn't match rule 1 but matches rule 2, it means that we take an action configured in the second rule and don't check any of the subsequent rules. So that's the logic here with the policy evaluation. Let's configure a simple security policy where we will permit some traffic. We will focus on just one direction. This is a simple demonstration where I want to show you how to configure the different settings, basic settings on the firewall. It's not about building, super fancy security policy for different zones. So we have just 2 zones, so it's actually there is no place to build a complex policy. It's going to be for the inside to outside or outside to inside direction. We will focus on this single direction. The goal is going to be to allow our internal clients, internal users to reach the internet. So I'm going to say that 10.11.11 is going to be my source. Internet is going to be the destination, which means that we will use any as the destination. We will be coming from the inside zone. We will be going in this direction, and we will leave for the outside zone. So this is going to be my source zone over here, and then outside is going to be the destination zone. Okay, and let's say that we want to permit the following communication. Our clients will use external DNS, so we will want to permit DNS. Maybe for DNS, let's be more specific. DNS to 8.8.8.8, and then let's permit web traffic, and I will say HTTP and HTTPS, and we will use what is known as the application-based config. Application-based configuration means that the firewall will rely on one of these special identification engines called AppID to distinguish between the different traffic flows. And this is a recommended approach for configuring policy rules because it gives us the ability of configuring more granular policies. The firewall is able to distinguish applications running on a single port from each other, so we can be much more specific when we use applications than just port numbers, which is a legacy approach, something that is no longer recommended to use, especially on a firewall like that supports application identification. Let's go ahead and take a look at this on the GUI. We will go to the Policies tab. The default security policy, as I said, is made of just 2 implicit rules, one for intrazone and one for intrazone communication. And if we scroll to the right, notice that the first rule, intrazone, is to allow the traffic versus the second is to block it. Okay, we will now configure custom rules for DNS and web communication just to show you that how to make the firewall allow certain traffic. I'm gonna call this first rule DNS, maybe in out dash DNS, and the rule type can be intrazone, and one other type I didn't say anything about. Universal means that it's actually it's like a combination of both. It combines the intrazone with interzone, which means that it will affect the traffic that goes within the same zone and also between the different zones. I always want to be specific when I build policy rules. I want to make it easy to understand what a rule is going to affect. So since we will be going from the inside to the outside, I want to make it clear that this is for interzone communication. In is going to make my source zone. For source addresses, we could either specify them here, like use the CIDR notation like that, or you could use objects. I'm going to use objects to make the whole configuration easier to manage. I'm going to call it len1, which is going to be a subnet 10.11.11.0/24. You could even assign tags with different colors to easily distinguish between the subnets. Maybe let me quickly show you how to do this when we are done with the policy configuration. My source subnet to the outside zone and destination address. Let's also configure it as object. DNS-server is 8.8.8.8. Application, in this case, what I want to use is DNS. There is tons of different applications available on PanOS. So it's good to have some experience to know what these are about. But if you have a problem, if you don't really know what the application is, I will show in just a second how to find it in the database to get some information that describes the application. The next step is service/URL category. If you use application-based config, in 99% of cases, plus you want to use application default, which means that the firewall will inspect this traffic as long as the application uses its original port, its protocol-specific port, which in case of DNS is going to be 53. And action is what I want to allow. We can log at the session start or session end. I'm going to leave the default action. Two more things before we proceed. I promised to show you how to configure tags. So let's configure to tags. I'm going to call it trusted, and we will give it a green color, and another one I'm going to call it untrusted or just external, or we will make it red. And now we will go back to the policy and update the role. So click on the role name. And let's click on the object. Let's say, okay, let's just go back. Let's go to objects and addresses, because really what I really want to change is the objects, not the zones. And I want to choose a tag from here. So len1 is going to be trusted, and DNS server is external. Okay, for the applications, you can take a look at them under objects and applications. You can use the search option to find an application name, or just look at the different categories and subcategories of applications. If we look for DNS, let's just enter and click on the application. In the second window below here, it is going to give us a description of what DNS is. And in case of certain applications like DNS base, it will give you information about the port number it uses. Okay, it should be sufficient for this session to really understand how we configure those different policy roles and how to select the application without going into too many details. Rule number 1 is for DNS. Now I'm going to click on it and I will say I want to clone. We will add second rule below. So that's the fastest way to configure a similar rule. Just want to clone it. And then click on the rule and change the name. Let's call it web. The source is going to stay the same. Destination is going to be changed to any this time. Destination zone is out. This time application is going to be configured as web-browsing. So this is not necessarily self-explanatory. And this is why I mentioned that you should have some experience with PanOS to know what application to use. The web is probably the most tricky. We've got 2 web applications that are used for HTTP, or basically clear text, and SSL is for encrypted web communication. So these 2 is what I want to include with application default set as the service here. Action allow and OK. Okay, I'm going to commit this configuration, but we will still not be able to test it because we will be missing one thing here in this network to allow the inside to outside communication, which is going to be network address translation. So let's now take a look at that and see how to configure it on the firewall. One more thing I want to go over in this course is network address translation. Network address translation is something that is enabled through a NAT policy on PanOS. Of course, NAT is what we will use to change certain information within an IP packet. In most cases, it's going to be the IP address itself for the source or destination. It could be port number. In our case, what we will want to modify change is going to be source addresses of the packets that are received on the inside interface of the firewall because of how the network is configured, which basically makes router 2 unaware of the inside subnets, inside addresses configured in these environments. So what we will want to do here is that we will want to change the sources from 10.11.11.0/24. So as they leave the firewall, they will show up with an IP address that is assigned from a range of, let's say, 192.0.2.41 through 45. There's 5 addresses for the pool. So this is going to be a new source of within the packet as it is sent to the internet, which means that when router 2 gets the packet, it is going to reply to this translated address, which it will know how to reach because it's a part of the connected network. Before we take a look at configuration, let me quickly discuss the policy for NAT. Each role, NAT policy role, is going to require a source and destination zone at minimum, and similar to security policy, and NAT roles will be processed in a top-down fashion, which means that we will start evaluating the policy with the rules that are placed at the top of the policy. We will check if a rule matches a packet. If it matches, we will perform a translation based on what the rule says. If we don't have a match, we will evaluate subsequent rules in the policy, which also means that for any type of specific translations, you should always put them first in the policy before any type of broader rules. If we don't have a match in the translation table, we will not perform that at all. Using objects is similar to what I showed you for security policy, is optional, but it basically makes the whole process easier to manage in the long run. Policies net is where we will go on the GUI to configure and net roles. It's going to be this table, by default empty, no implicit roles. I'm going to say add internal clients net is going to be name of the role. IP version 4 is going to be the type. And now the original packet, or just the packet that they want to change, this packet is going to be coming in the inside zone. It will be destined to the outside zone. And the packet will be coming from my LAN 1 clients. No matter what the destination is, it's for all packets sent to the internet. So this is what describes the original packet. Now the second column says, do you want to make a translation, and if yes, of what type? I can use configure dynamic net with a pool, a dynamic net with a pool and path. I can do static net, or I can say that this communication I want to explicitly exclude from translation. In our case, it's going to be dynamic translation. We will configure a pool. We will want to configure a pool first before we select it under translated addresses. It seems that I am not able to configure the addresses from here. And then we will leave the destination address translation as none. Okay, so let's cancel for a second. Let's go back to objects. So pool addresses is the only exception to objects for net. If you want to do a dynamic net, you want to define a pool for an address object. Net pool. This is a range 192.0.2.41 through 192.0.2.45, like that. Okay, let's recreate this rule. Give it a name. Inside this, the source zone. Outside is the destination zone. The addresses we want to change is our LAN clients. Then choose the translation type and select the pool. Configure it over here. Leave the destination translation as none. Okay, so inside to outside, this source in the packet, LAN 1 clients, translation will be done dynamically using this pool. No destination address changes. Once again, we only change the sources here. We leave the destination address intact. Okay, so with that in place, we should be eventually able to test this configuration. I'm going to connect to the user PC. The user PC is configured with a default route pointing to router 1. Let's double check. We will open up a browser. And we will try to connect, let's say, to cybrac.com. And let's also try to get to, well, we see you can access Google, maybe CNN. Okay, we see that we can definitely connect. We can definitely browse the internet with this simple configuration. And now the way that I would verify this, first and foremost, I would take a look at the security policy or just net policy. Pay attention to hit counts. That's probably the fastest way as how you can verify if the traffic matches your configuration. We should see the hits for the net policy and also for the security policy. So we see that these go up. And another place would be to go to the Monitor tab. First and foremost, I would scroll down to the session browser. The session browser is going to show you the existing connections across the firewall. And I would also take a look at logs. Just remember that the difference between session browser and logging is that the session browser is only going to show you connections that already traversed through the firewall. So connections that are up, operational, or that were just terminated, versus logs will show you everything, assuming that the session in our case ended because we configured our policy rules to log sessions at the end. If the session was still up, meaning it hasn't terminated, we wouldn't see an entry in the logs until the session is over. You can change this by configuring to log traffic at the session beginning instead of the end, in which case you would see a log entry immediately in this table. That's pretty much it what I had at this time. I hope you guys enjoyed this course. If you are looking for more specific information about the different topics covered in this course, go ahead and take a look at www.cybrac.com. You will find a bunch of courses for PanOS and other appliances, other types of firewalls, other types of IT security content. So just go ahead and visit us on cybrac.com. Thank you, everyone, and until the next time.